Watch. If I say 5x squared plus 7x, what is this guy counting? The number of x squares. And this one's counting the number of x's. Can I consolidate those? No. I can't. Those are not like terms because they're not counting the same kind of thing. So that's what like terms means. Like terms more specifically, more analytically, like terms is the same variable and the same amount of each variable. So here there's two x's there, right? X squared. And these each have one x, right? So this would be x squared plus x squared plus x squared plus x squared plus x squared. And this would be x plus x plus x plus 7 times, right? Yes?
You said that terms are separated by plus and minus, but they're connected by what?
Multiplication. Isn't this 4 times x squared? I like it.
Okay, sorry.
So that's one term because it's all the pieces of the term are connected by multiplication. And then you have a minus. And then the next term comes, connected by multiplication. Then plus, and this poor little dude has nobody with him, but he's still a term. Poor little 3. Yes, ma'am?
So even though you can't combine them, you would write that 5 and then you would put parentheses x times x parenthesis plus 7x? How would you write
You
that?
could, but there would be no reason to do that.
I know, but to break it out.
You could write it like that, but there really truly is no reason you would do that. Yeah. Right now you can see problems like write x squared in expanded form, but this is the preferred form. It's more compact. So you wouldn't really see this kind of question to write it out. Because then people might think this is like terms now. It still isn't. So let me ask you this. Sorry. Everybody awake? All right. Cool. What up there can I put together? What up there is like terms? Yeah, what goes with this guy? Yeah, good. Those are like terms. I see 4 y's over there, 6 y's over there. So how many y's do I have? 10 y's. Does everybody see that? I'm just consolidating. Why write 4y there and 6y there and the same expression? I just write 10 freaking y's and get to the point, right? So there's 10 freaking y's. And then, of course, what goes with this? Yeah. Negative 7 of these plus 8 of these is 1. And you don't have to write the 1, right? You can just write plus y squared. I can see that it's only one of them. That's an understood 1. What do we call this number, by the way? The number that's in front of the variable. What do we call that?
The base.
Now, the base is what's being raised to a power. The number in front of the variable is the coefficient. I like it. So the coefficient, so here the coefficient is 4, the coefficient is negative 7, right? Here the coefficient is negative 2, here it's 5. The coefficient is the number in front of your variable stuff in a term. Does that make sense? Have you guys heard that word before? The words aren't as important as being able to do the work, but the words are still important. Yeah?
So is that called simplifying what you just did with this example?
This is simplifying. I love it. Simplify means do the operation. So what are the operations here? Subtraction and addition. And we did it. Yay. And can I go further with this? Hell no. Right? I don't have 11 anythings. I have 10 of those plus 1 of these. I can't put them together anymore. I like it. Cool. Let me stop there for a second. You guys, I'm not going to have a good time trying to read you. You're all slightly concerned, but nobody's saying anything. Your faces are all like... So I don't know. Okay. Blah, 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 blah. Page 130, they have a bunch of... we went over that to translate to words. Translate from math to English, so they have some more words there. Okay. So that's section 2.2, and we touched on all those ideas the other day, last week.
If the subtraction sign was by the 8, would it be a negative?
Yes, totally. I like it. So, for example, let's do one more of these. So, are they all like terms? Are all of them like terms? No. Totally not. Because who goes with this? 7 ABs can go together with what? Negative 2 ABs. So how many ABs will I end up with? 5 ABs. So if you say it like that, doesn't that make any sense? You're just consolidating. If I see a chair and another chair, I got 2 chairs. But if I see a chair, and a table, I don't have 3 chair tables. I got 2 chairs and a table. Does that make sense? So I see how many? So I see 5 ABs, and what does this guy go with?
The negative 9.
Yeah, so many B's, right? So I got 6B minus 9B, negative 3B, and then that's it. That's all I can do, because these are not like terms. I like it. Coolness. Okay. Now for this, the same problem, they could then tell me what A and B are. I would plug them in and then solve it, right? But until they tell me what A and B are, there's nothing more I can do. All right. Oh, and I forgot what I was going to do. Blah, 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 blah. Okay. Oh, good. Let's get into this. Here we go. All right. So any questions about what we just went over? How do you guys? So we just recovered 2.1 and 2.2.
I have a quick question. The way you, there was one problem you did right now where it was like 6 and it was the equal sign with a line in between it. What's that called? How would we write that?
In English?
Yeah.
Not equal to. Or
Not-
doesn't equal.
Does it equal to?
Doesn't equal, not equal to. So you'd write, if I saw 6, this 7 would be 6 is not equal to 7. Or 6 ain't 7. 6 just don't be 7. 6, just capture the idea that those are not equivalent. I like it. This is just a slightly more specific way to say that same thing, right? They ain't equal, and more specifically, 6 is less than 7.
And if there's if there's still more stuff behind the 7, you still write it out though, right? So 6 is not equal to, let's say 7 minus 4 to the 3rd power.
Sure. So 6 is not equal to 7, decreased by 4 to the 3rd power, yeah. Yeah, I like it. Now, real quick, there is a purpose for this symbol. Do you guys remember what is it you cannot divide by? 0. We talked about that for a little while the first day, I think. So if you saw this, what could x not equal to? 0. So you would say x can't be 0. Because what is 1 divided by 0? Oh shit.
Wait, what?
What is 1 divided by 0? We talked about
0.
that. No. Undefined. How do you make 0? 0 divided by anything is 0.
Okay.
If I got no money,
Switch.
how much is everybody? Let me divide that amongst everybody. You all get nothing. Right? But if I try to divide by 0, that's freaky as shit. Right? We talked about why that is before. But I just wanted to show you one application of this symbol. It's not just we went, let's put a line through it and mess them up. No, there's a reason for it. I want to identify what my variable can't be. I like it. So there's a reason for everything we do, believe it or not. It's not just to give you stuff to do. What would that mean about my life if that was true? Man, you know, this guy majored in shit that make us do stuff. No, there's reasons for it. Okay, so what I want to focus the rest of this the class time on is we're going to get into really basic equations. All right. So let me see. I got a little handout for this too. Let's talk about it for a minute. So, I mean, equations are the bread and butter of computational mathematics. So if you want to predict the weather, you set up an equation that models the weather. Not an easy thing to do. If there's an asteroid headed towards Earth, and you want to shoot a rocket to blow it up, right? So you don't have to send Bruce Willis and everybody else up there, right? You guys sort of with me? You have the equation for the meteorite. Guys, there's an equation that says where that will be at some time. I plug a time in, and I can see where it's going to be. We can calculate that. We can set up an equation. Then I make an equation for my rocket. And if it's not right, oh shit, we're going to miss, then we change the equation by changing the inputs on the rocket launcher. Are you guys kind of with me?
The coordinates.
Yeah, the coordinates, exactly. So it's the equation of motion. How is this thing going to move through space? I want to make sure that it hits that it doesn't go, oh, or oh. I want the equations to equal each other. Bam, boom, and then maybe we're safe. Or maybe just all the parts come down and kill us anyway.
It could happen.
It could, actually. It's kind of scary. Don't think about it too much. They see stuff. I'm not going to tell you. I'm sorry. Let's not think about it.
That was recently.
Yeah. They say, like, oh, look, something almost hit us. Oh,
Yeah.
Okay, well.
I bet it was a lot closer than they.
It's a lot. Yeah.
Yeah.
Let's not dwell on that. Don't live your life based on that. So I just want you to realize, equations are, again, they're not just an exercise in we need to give these students something to do so that before they get their degree. This is used everywhere, the idea of equations. So what the hell are freaking equations? Well, can somebody give me an example of an equation? All you got to do is make sure that there's an... Okay, somebody give me an example.
6 plus 5 equals.
Yeah.
What have you?
11. That is an equation, but is there something to solve here? No, but it still is an equation because there's an equal sign in there. So what's an equation that I have to solve then that's related to this? Maybe I can, instead of 6, I'll just put X. And then I already know what the answer is going to be, right?
Solve for
The answer's got to be what? 6, because that's what makes it true. So when you solve an equation, you are finding out what values of the variable make it true. That's what you're doing. Yes, sir?
11 minus 5.
Exactly. We're getting there. I love you guys. All right. Yes, sir?
This is 2.3.
This is 2.3. 2.3. I like it. So now watch this. I like to start kind of backwards here. Let me see if you guys kind of get this. I do this on the handout. If we start with x equal to, give me a number. 5. Sorry for the 7. It's just gonna. If x is 5, let's just say we know that x is 5. What would x plus 2 have to be?
7.
7. Don't you? Some of you guys are thinking the wrong way. If x is 5, so if you're 5 years old, in 2 years you'll be 7. To maintain the equality, if I add 2 to one side, I better add 2 to the other side. You can imagine they often call equations the little balancing scales. So if you add 2 to one side, you better add 2 to the other side to make it stay equal. Does that make sense? I always think about Indiana Jones, and he didn't balance his equations right because the freaking boulder came down, Oh, shit. He should have studied more sand math, I guess. I don't know. No? Have you guys seen Indiana Jones?
Yeah,
Temple?
there's some
I know it's Indiana Jones Raiders of the Lost Ark. I know it's a while back, but he used to be young. Everybody used to be young. Let's see. So if x is 5, x plus 2 is 7. That's true. If x is 5, what's 2 times x? 10. Do you guys understand? If x is 5, twice x has to be 10. You guys with me? So one way to look at equations, and this is not where equations in the real world come from. We don't go, we know the answer, no, we don't know what the freaking answer is. We set up equations and then solve them. But this is my attempt to make sense of why we solve them the way we do. When I'm given an equation, like if I was given the equation this, my thought process is, somebody did something to x. I want to undo it so I see what x must have been. So what did somebody do to x here?
Added 3.
They added freaking 3, those dorks. So what are we going to do to undo what they did?
Minus 3.
We're going to subtract 3. And I can't just subtract 3 from one side. I have to subtract 3 from the other side also. Or else the boulder rolls and we got to run. Right? Do you guys get the idea? It explains why we do what we're doing. We're trying to recover what x itself must have been. So we're trying to undo the shit somebody else came and did to it. Poor little x is sitting there and then somebody, I had 3, you had. We're like, oh shit, x, we got you. Let's take the 3 off of you. And now what was x? 8. How do I check that? Just plug it back in. To see if this is true. If x is 8, how do I rewrite this? 8 plus 3. Does that equal 11?
Yes.
Check. So I know it's true, because when I plug the value back in, it ends up with a true statement.
Do you plug and chug the 3 colors?
Plug and chug, exactly. You still get a kick out of that. I like it. What'd you learn in school today? Plug and chug. It's just so weird that you guys have never heard that before. Alright, so what about this? What if I had this equation here, 4x equals 28? What do you do to it to solve it? What did somebody do to the poor x? What did they do to the poor x?
Multiplied by 4.
Multiplied by 4. So how do you undo what this person did? Divide by 4.
Divided by 2.
So equations are all about doing the opposite of what's there. So you can get x by itself. Are you guys with me? I know when I talk slow, that's a key thing to you. That is an important thing I'm saying. Everything I say is important. Maybe not. So when I divide this side by 4, I better divide this side by 4. So then x must have been 7.
7.
And then if you go to check it, 4 times x, well x we think is 7. Is 4 times 7, 28?
28.
Yes. Now, all of these equations represent one thing being done to the x. Some of you guys know, for example, we're not going to work this problem out, but I just like to do this just to freak the shit out of you. But you're all like, dude, you do that already, don't you? We're not going to solve this yet, but in our future would be a problem like this. Alright, so that's just in case you guys are all like, what the freak is all this algebra shit? I knew the answer was 7. I didn't need you to be doing no divided by 4 crap. Alright, can you just look at that and tell me what the answer is? I don't think, if you can, teach me. Right? I want to learn from you. So algebra, so my point with this is, don't just put 7 and keep going. I have got to see work. And if you're like, well, that's too easy for me. No, this is you getting used to the steps. Because then when you hit that, you want to know the steps and how they look and how they work. I like it. So, yeah, we're not going to try that one yet. We got a little bit of stuff to get through before we even try that one. So let me ask you this. I'll leave that up there for a second. What if I ask this? Is x equal to 11 a solution to... what you got, Jeff? 14 minus x equals 2.
Strong. Strong. 14 minus 11, 3.
And so how do you check it? What do you do to check it? You just plug it in, right? So if you take 11 and you put it in, does it result in a true statement? Is 14 minus 11 2?
False.
No. So what does that mean? What does what we just did mean? What does it mean? No, what we just did, what does it mean? No, be careful. It doesn't mean that there's no solution. How many solutions, possible solutions, did we just check? One. How many possible solutions are there in general? Infinite number. So if you want to do it that way, you got to check every number in existence. Let's know. So what we just did was we saw that 11 is not the answer to this. There is an answer to this. It just happens to not be 11. Are you guys understanding? So is x equal 11 a solution to this? No. Not no solution. You could write 11 not the solution. Sure. But don't say no solution, because then you don't know if there's no solution. There is a solution. 14 minus what is 2?
14 minus 12.
14 minus 12 is 2, right? So you can just see that.
Well, it wouldn't be undefined either.
Oh, no. Yeah, definitely not undefined.
Not the variable.
You with me? The answer is 12. Can you guys just see that the answer is 12? 14 minus 12 is 2. So the answer is 12. So when I say is x equal 11 the solution, well, of course it ain't. Don't say no solution. Don't say undefined. All we know is that 11 doesn't work. That's all we know. So we say, no, 11 doesn't work. 11 is not the solution. Don't say no solution. That's a big step to take. That didn't work. Can't be any answer. Where are my keys? Not here. I looked everywhere. Screw it. I can't find them. Right? I mean, we haven't tried everything at that point. You can't say that much. Okay, let me take that away. Okay, let me do this. Let me give you this handout so I can finally shut up. I don't know if I brought enough now with all the busload of people I got in here. Just to... Yeah, so the side that says solving basic equations. You can work alone or with other people near you if you want to. It's up to you. I want you to read through that and then try the problems out at the end. Okay. Don't worry about the back side of this. Do the solving basic equations side. Might have enough. Good.